What if the world's biggest mysteries aren't out in space, but hidden under the ocean? Take Korea's Busousan Tunnel, built with amazing precision, or Japan's earthquake-resistant Xiao Tunnel that still has experts puzzled after all these years. These underwater tunnels go against everything we think we know about engineering. In this video, we'll explore some of the most surprising underwater tunnels that even today's engineers can't fully explain. Before we get started, be sure to smash the like button, subscribe, and click the notification bell for more such amazing content. Dalian Bay Tunnel. Ever heard of a tunnel so advanced it's making US engineers rethink their methods? That's China's Dalian Bay Undersea Tunnel. Opened in May 2023, this 3.17-mile expressway runs under the sea, connecting the north and south sides of Dalian Bay. The tunnel is made from 18 huge sections, each weighing about 132 million pounds. That's like sinking 18 aircraft carriers underwater. It's packed with nearly 40,000 sensors that track things like air quality and visibility. Smart fans turn on by themselves to keep the air fresh, and the lights adjust automatically depending on the time of day and weather. It's like the tunnel can think for itself. Building it was no easy task. Engineers had to work through freezing winters with temperatures below -4 degrees Fahrenheit and deal with difficult underwater terrain. They even created a brand new floating method to lay the tunnel without harming the seabed. Thanks to this cutting-edge work, a trip that used to take an hour now takes just 5 minutes. It's completely changed how people move around the city and given a big boost to Dalian's economy. Channel Tunnel. Does the Channel Tunnel really add up when you take a closer look? On paper, it's an incredible achievement, a 31-mile tunnel linking the UK and France beneath the English Channel. But the more you look into how it was actually built, the more questions start to surface. This tunnel passes under one of the busiest and most unstable waterways in the world. The seabed is far from ideal, filled with soft chalk, shifting layers, and intense water pressure. Yet, engineers managed to carve through it with near-perfect precision. The tunnel officially opened in 1994, and even today, experts are still debating how some of it was done. Certain parts of the construction, especially the waterproofing and ventilation systems in low-pressure zones, remain puzzling. Some of the building techniques weren't well documented, and there have even been whispers that some of the tech used wasn't standard or widely known at the time. And here's the strangest part. Despite its size and the extreme conditions it endures, the tunnel has required surprisingly little maintenance. It continues to operate smoothly after decades. So how exactly did they build it? And what secrets are still hidden in its walls? Tokyo Bay Aqualine and Bohai Strait Tunnel. Ever wondered how a tunnel can survive in one of the most dangerous and unpredictable bays on Earth? The Tokyo Bay Aqualine doesn't just survive, it thrives. This 9-mile-long structure is a mix of bridge and tunnel, connecting the cities of Kawasaki and Kisarazu. Half of it runs underwater, beneath a bay constantly rocked by tides, typhoons, and earthquakes. Building here was a huge risk. Engineers used cutting-edge technology at the time, but even today, some details, like how they stabilized the shifting seabed or managed the pressure change between tunnel and bridge, remain unclear. Some of the construction methods were never fully documented. Experts admit they're still not sure how it's holding up so well under non-stop stress. Now imagine something even bolder. China's proposed Bohai Strait Tunnel. It's not built yet, but it's already making waves. Planned to stretch a staggering 76.4 miles under the sea, it would become the longest underwater tunnel in the world, nearly 3 times longer than the Channel Tunnel. This $43 billion mega project would cut a 12-hour road trip down to just 1 hour by loading vehicles onto high-speed trains running beneath the Bohai Sea. The challenges? Everything from boring through active fault lines and unstable seabeds to maintaining safety and protecting an ecological zone, the Changshan Archipelago. It would take over a decade to complete and require massive advanced tunneling machines. Is it visionary genius or a risk too big to handle? Either way, the Bohai Tunnel is a puzzle the world is still trying to figure out, and the US hasn't even dared to attempt. Pearl River Tunnel. US engineers are still scratching their heads over this one. China's Hong Kong-Zhuhai-Macau Tunnel, part of the massive sea bridge system, is one of the most surprising feats of modern engineering. Opened in October 2018, this 4.16-mile underwater expressway connects Hong Kong, Zhuhai, and Macau, creating a fast and seamless route beneath the Pearl River Delta. Built from 33 giant tunnel segments, each weighing around 176 million pounds, this structure is an underwater heavyweight. Packed with advanced sensors and monitoring systems, the tunnel constantly tracks everything from its structural integrity to air quality. Automated safety systems respond instantly to any change, keeping the entire route safe and efficient around the clock. The construction process was extremely challenging. Engineers had to work through harsh typhoons and deal with complex underwater geology. To make it happen, they developed new foundation-laying techniques that reduced disruption to the sensitive seabed. The payoff? A journey that once took hours now takes just 30 minutes, revolutionizing transportation in the region and giving a major boost to the local economy. It's a bold achievement that's still raising eyebrows around the world. The Qingdao Bay Tunnel. In 2011, China quietly completed a project that still has US engineers amazed: the Qingdao Bay Tunnel. This 4.85-mile underwater highway links Qingdao's city center with the Huangdao district, functioning like a high-speed express lane beneath the sea. At its deepest point, the tunnel plunges 243 feet below sea level, slicing through 14 fault zones and over 22 different types of rock. Tackling this complex geology required cutting-edge solutions: digital water detection systems, high-precision grouting, and a custom waterproofing technique developed specifically to keep the ocean out. Opened on July 1, 2011, alongside the record-breaking Jiaozhou Bay Bridge, the tunnel instantly transformed transportation in the area, cutting travel time from over an hour to just 5 minutes. The result? Less traffic, faster commutes, and a major showcase of China's engineering capabilities. But China isn't stopping there. A second tunnel is already under construction, set to stretch 9.87 miles beneath the bay, making it the longest undersea road tunnel in the world. It's being built using a massive 541-foot, 11.7 million pound shield tunneling machine called Deep Blue. This giant not only bores through brutal seabed conditions, but also recycles water and reuses excavated rock, making the project more sustainable. This isn't just infrastructure, it's innovation with a message. China is leading the race beneath the sea. Sydney Harbour Tunnel. At first glance, the Sydney Harbour Tunnel looks like a straightforward solution to city traffic. It links Sydney's north and south beneath its iconic harbour, helping thousands of vehicles bypass surface congestion each day. But dig a little deeper, literally, and you'll discover a tunnel that still puzzles engineers, even decades after its completion. Built using an immersed tube method, giant concrete segments were lowered into a trench on the harbour floor. The challenge? Sydney Harbour isn't exactly calm. It's known for strong tides, shifting currents, and soft, unstable seabed material. Yet the project went ahead without a hitch. The tunnel was laid down smoothly and has remained rock solid ever since. No major leaks, structural damage, or ongoing issues, despite the constant stress from water pressure and daily traffic. That's what has experts scratching their heads. Some of the waterproofing and foundation techniques used were so advanced, they're still considered ahead of their time today. And oddly, some of that technology was never reused elsewhere. Why? No one's quite sure. There's even talk that the tunnel somehow absorbs pressure and vibration like it has built-in flexibility, without any clear explanation of how. The Sydney Harbour Tunnel isn't just a traffic fix. It's a quiet engineering marvel that holds more secrets than most people realize. Janjang Bay Tunnel. Crossing Janjang Bay used to be a slow and frustrating experience. Long detours, unreliable ferry rides, and delays due to bad weather. But China has completely rewritten the playbook with the Janjang Bay Undersea Tunnel, a groundbreaking achievement for high-speed rail travel. Stretching 5.99 miles, this tunnel isn't just long, it's a major engineering milestone. Most of the tunnel, about 4.69 miles, was carved out by a single massive tunnel boring machine, TBM, named Yongqing. With a diameter of 47 feet, this TBM drilled as deep as 561 feet below the seabed, enduring extreme pressure, about 7.4 pounds per square inch, or nearly 11.5 pounds pressing on an area the size of a fingernail. Why go for a tunnel instead of a bridge? Several smart reasons. It protects the beautiful skyline of Janjang Bay, reduces harm to marine ecosystems, avoids blocking major shipping lanes, and is more resilient against typhoons. All of this makes for a safer, more reliable route for high-speed trains. This tunnel is a vital part of the 249-mile Guangzhou-Janjang high-speed railway, slashing travel time between the two cities from over 2.5 hours to just 90 minutes. It's a massive win for commuters and another bold example of how China continues to push the limits of engineering innovation. The Busan-Gyeongju Fixed Link. Most people driving through South Korea's Busan-Gyeongju Fixed Link probably have no idea they're traveling through one of the world's boldest underwater engineering feats. But this tunnel bridge combo is so advanced, even seasoned engineers are still amazed it was pulled off so flawlessly. Spanning over 8 miles, the structure connects the bustling port city of Busan to Gyeongju Island, slashing what used to be a 2.5-hour journey down to just 40 minutes. The real engineering magic lies in the 3.2-mile immersed tunnel segment buried beneath the sea. Unlike typical tunnels bored through rock, this one was assembled using pre-built segments that were floated out, lowered into a seabed trench, and sealed together with pinpoint precision. This wasn't calm water. They had to deal with strong currents, typhoons, and an unstable ocean floor. Yet each massive section was placed with tolerances down to fractions of an inch. A single mistake could have led to catastrophic leaks or misalignment. And yet, it works perfectly. No major maintenance issues, smooth traffic flow, and the structure shows minimal wear despite being constantly battered by underwater forces. For a tunnel that lives under relentless ocean pressure, this one is quietly legendary, a true testament to South Korea's engineering prowess. The Iiken Tunnel. How did Norway build something that still seems impossible? The Iiken Tunnel, often misheard as Iiken, holds the title of the deepest undersea road tunnel in the world, diving an incredible 947 feet below sea level. That's like driving at the bottom of the ocean, with only layers of concrete and steel keeping the crushing water pressure at bay. Originally built to connect a few quiet communities in western Norway, this tunnel wasn't meant to make international headlines. But once people realized just how deep it runs and how incredibly stable it has remained, it quickly became a legend in engineering circles. Constructing it wasn't easy. Crews had to bore through unpredictable rock formations beneath icy, high-pressure waters, all while facing constant threats of collapse. And yet, they made it work. Today, cars drive through the tunnel like it's just another road. No drama, no issues. What's baffling is how little is known about the exact techniques used to seal and reinforce the tunnel at those extreme depths. Maintenance reports are minimal, and no major problems have been reported since it opened. Meanwhile, newer tunnels in much easier environments often struggle with cracks or leaks. The big question still remains: how did Norway pull this off so flawlessly? It's a quiet marvel beneath the sea, and a mystery that continues to impress experts around the world. China's Haikang Undersea Enigma. Some tunnels are impressive, but the Haikang Undersea Tunnel in Xiamen, China, feels like it breaks the rules entirely. At first glance, it just looks like another ambitious part of China's expanding infrastructure. But dig deeper, figuratively and literally, and things start to feel off. This tunnel runs beneath Haikang Bay, linking Xiamen Island to the mainland. Building anything here should have been a nightmare. The area has a soft seabed, strong tidal currents, and unstable underground pressure, conditions that usually delay or even cancel projects like this. But not this time. Construction went quickly, with minimal problems, and years after opening, the tunnel is still holding up flawlessly. That alone has engineers scratching their heads. Under a mile of unstable marine terrain, and yet, no cracks, no leaks, no real issues. And then there's the tunnel's lighting system. Sure, it's high-tech, but some reports say it automatically adapts to visibility conditions and even driver behavior. How exactly? That part remains unclear, because full technical details haven't been made public. The whole project feels a bit too perfect. Smooth build, smooth operation, little explanation. It's left many wondering, what kind of tech did they actually use? And why is so much of it under wraps? Whatever the answers, one thing's certain. The Haikang Tunnel isn't just an underwater connection. It's an unsolved engineering mystery that still stirs curiosity around the world. Gintang Tunnel. China's Gintang Undersea Tunnel isn't just another infrastructure project, it's a record breaker in the making. Stretching 10.5 miles beneath the sea, this high-speed rail tunnel will be the longest of its kind once completed, setting a new global benchmark for underwater rail construction. Connecting Ningbo's Bailun district to Jintang town in Zhoushan City, the tunnel is designed to slash travel time from 90 minutes down to just 26 minutes. But what makes it truly remarkable isn't just the speed, it's the impossible-sounding conditions it's being built under. Two colossal tunnel boring machines, Dinghai and Yongzhou, are carving their way through 28 different geological layers, facing intense challenges beneath the Gintang Channel, a heavily trafficked shipping lane. At its deepest point, the tunnel plunges 256 feet below sea level, navigating not just water and earth, but also critical infrastructure like oil pipelines, seawalls, and busy ports. Each TBM is equipped with 308 custom-engineered cutters designed to handle corrosive marine pressures and unstable sediments without faltering. The precision required is staggering. One miscalculation could mean flooding or collapse. When finished, the tunnel won't just connect islands, it'll plug Zhoushan directly into China's massive high-speed rail network, cutting the trip from Zhoushan to Hangzhou from 3.5 hours to just 77 minutes. The Gintang Tunnel is more than a transportation project. It's a symbol of China's relentless push into next-level engineering. Jinnan's Yellow River Tunnel. Once a menace to cross, the mighty Yellow River is now home to one of the world's most impressive feats of tunnel engineering, the Jinan Huang Road Tunnel. This project isn't just big, it's the largest diameter underwater shield tunnel on the planet, stretching 3.58 miles beneath China's Mother River. At the heart of this operation is Shanhei, a massive tunnel boring machine, TBM, wielding a 57.4-foot cutter head powered by a staggering 7,510 horsepower. It bores through unforgiving materials, clay, silt, sand, with ease, thanks to a specialized air cushion pressure system that can endure up to 218 pounds per square inch. That's pressure strong enough to crush steel if not handled correctly. Even more astonishing, the underwater shield section was completed in just 110 days, a world record for a tunnel of this scale. The tunnel isn't just a hole through the earth, it's a double-decker expressway, boasting 3 lanes in each direction, designed to streamline travel between Jinnan's city center and the rapidly developing economic zones beyond the river. Challenges like managing the slurry waste were solved using jaw crushers and high-efficiency filter presses, proving that innovation wasn't just in the digging, but in the cleanup too. Bumlaf Tunnel. Can a tunnel really plunge over 850 feet below sea level and still function flawlessly? Welcome to Norway's Bumlaf Tunnel, an undersea marvel that continues to baffle engineers even 2 decades after opening. This tunnel connects the island of Foino to the mainland near Spisøy, forming a key part of Norway's Triangle Link highway system. On paper, it seems like just another infrastructure link, but this tunnel is anything but ordinary. Carved beneath the Bumlafjorden and surrounded by rugged seabed and intense underwater pressure, it ranks among the deepest road tunnels on Earth. Since opening in 2000, it has operated without a single major incident. No flooding, no structural failures, not even significant wear. That's over 20 years of silence beneath crushing marine pressure. How is it possible? The tunnel survives in an environment where failure is just one pressure fracture away, yet the methods used to stabilize and seal it remain mostly under wraps. Some suspect Norway used advanced techniques that never made it into the public domain. With its near-perfect track record, the Bumlafjord Tunnel doesn't just defy expectations, it might defy logic itself. Taihu Tunnel. Crossing Taihu Lake used to mean long detours or ferry waits. But in December 2021, China flipped the script with the opening of the Taihu Tunnel, its longest underwater highway tunnel, running 6.7 miles beneath the country's third-largest freshwater lake. Part of the broader 27.3-mile Changzhou-Wuxi highway, this tunnel is more than just a shortcut. It's a sustainability statement. With a width of 143 feet, a height of 24 feet, and 6 traffic lanes, it's one of the most expansive underwater tunnels ever built. But what makes the Taihu Tunnel a global benchmark is its green tech. Construction began in 2018, and from day one, the team focused on minimizing environmental impact. Advanced automated steel processing, intelligent construction systems, and zero-emission protocols ensured no sewage or dust discharge during the build. The Taihu Tunnel isn't just an engineering marvel, it's a symbol of eco-conscious infrastructure. It sets the bar not only for what can be built, but for how it should be built. Shenzhen-Dongshan Link. What used to be a frustrating detour across the Pearl River estuary is now a swift 30-minute drive, thanks to the Shenzhen-Dongshan Link, a 15-mile mega-project that redefines what's possible in marine transportation. This isn't just a tunnel, it's a multimodal engineering wonder, combining two massive bridges, two man-made islands, and a 4.2-mile undersea tunnel into one seamless route. The tunnel itself is the world's longest and widest underwater steel shell immersed tube, designed to carry 8 lanes of traffic. But this isn't just about size, it's about precision and safety. The link smashed 10 world records, including the largest offshore steel box girder suspension bridge span, 5,466 feet, and the highest marine bridge deck, nearly 299 feet above sea level. Safety features are next level. Intelligent inspection robots, dual wavelength flame detectors, and a central utility corridor make this a model of modern tunnel design. After 7 years of construction, it opened on June 30, 2024, transforming regional mobility and injecting new energy into the Greater Bay Area's economy. It's not just a connection, it's a vision of the future. The Transbay Tube. Beneath the San Francisco Bay, one tunnel continues to puzzle engineers nearly 50 years after it opened: the Transbay Tube. It's a critical part of the BART system, linking Oakland and San Francisco, but it's also one of the most mysterious underwater structures in America. Completed in 1974, the tube was made of prefabricated steel and concrete segments, sunk into a muddy trench right along a major earthquake fault line. That's right, a submerged tunnel built in earthquake country. And yet, there's never been a major structural failure. Decades of relentless saltwater corrosion, seismic activity, and pressure fluctuations, and this thing still runs like a charm. Engineers retrofitted the tube for added seismic resilience, but even the original 1960s design somehow exceeded modern safety expectations. In tests, parts of the structure were found to be stronger than current-day standards require. Was it foresight? Luck? Or did those Cold War-era engineers tap into something we've overlooked? The Transbay Tube isn't just a transportation corridor, it's a mystery we're still trying to solve. Got a favorite tunnel from this list, or one we missed? Drop it in the comments. More mysteries are coming. Stay curious.